and it is used to classify the upcoming data or new data based on the features available newly arrived data will be classified. In the second category, what is called as the unsupervised machine learning algorithm. So in this, there is no need of a class. So here, the main contribution is from the training data set, the points present in your data set or similarity between the data points present in the data set, then it has to group the similar process or similar data points into one group and another, that is dissimilar data into another group. The best example is intra-cluster similarity should be high and inter-cluster similarity should be low. So the next thing is, the third one is semi-supervised learning algorithm. So training data, but what is happening here means it is trial and error method. So it is based on if the movement mainly called as reinforcement learning algorithm. So in machine learning paradigm, there are three different broad categories of algorithms available. So in this, what we discussed in supervised concept of certainty. What is certainty means? We need to yes, if this is the that is from the class labels, the this data set may or may not happen. So those types of problems belongs to a category called uncertainty types of problems. So whereas in that I think in unit one, you propositional logic. So these first order logic and the propositional logic belongs to certainty problems. So that we can have a clear idea from the predicate what we can get. So that is called certainty type of problem. Whereas in today's topic, in today's session, we are going to discuss about probabilistic reasoning. So in this probabilistic reasoning, machine has to deal with uncertainty present in your data set. So with this type of knowledge representation, we can write, for example, A tends to B. So what is the meaning of certainty and uncertainty case, whatever it may be? The meaning is that if A is true, then B is true. That is the if you are came across a situation where we are not sure about whether this particular A component is true or not. So in that case, if A component itself is, it is not possible to know about whether it is true. Knowledge representation, if A is true, then B is true. So if the particular concept or particular condition A, whether true or not, will not be happen, or it is not possible to say. So this particular situation is known as uncertainty. So if any one of the things or condition that itself is not sure, then from there more. So that is the concept behind uncertainty. So to represent this particular type of uncertainty knowledge, where we are no not sure about the predicates. So in this situation, we are in need of some uncertain reasoning or probabilistic reasoning. So the basic concept behind probabilistic reasoning uncertain environment, or it is not sure about this will happen or will not happen, then in that, so what may be the causes of uncertainty? There may be lot of reasons why this uncertainty can happen. One such reason is in machine learning paradigm, as you all aware that if the training data set is perfect, if the training data set is best, if the training data set is without processing techniques, so we are going to work with pre-processing techniques in order to remove the errors or missing data not possible to do directly to the machine learning algorithm. We have to do some preliminary work for that. So after doing all these things, if you give your data correct in all aspects, then that particular data will be used by the machine learning algorithm, and the result produced by the algorithm only the machine learning algorithm will produce the output. So if your data is a not reliable one, it is not from reliable sources, then we cannot apply the cannot get the better result from that particular type of unreliable data. So this particular type of unreliable data leads to uncertainty. Then second one is experimental errors. When we apply industrial machine learning purpose. So when we apply machine learning algorithms to industry, according to industry 4.0 norms, lot of applications is working, how the machine that is at what is the lifetime of the machine, because if the machine is not working, if you feed the data, and if that particular component, I am talking about mechanical way, so if that particular component it is not possible to get the output that particular component, then to production level or even distribution level, anything can, some errors can happen. So if these errors, if you don't deal that particular, definitely uncertainty will happen. And third one is equipment fault, machine level equipment fault. If you don't know about the equipment is a fault, produce, either it will stop the process or it will produce the components with the defects. So in that case, uncertainty can happen. Then can happen. So due to temperature variation also, some uncertainty can happen. And finally, climate change. So these are all the reasons, or that is causes. Due to this only, this uncertainty probabilistic reason. So it is a way of knowledge representation, one way of knowledge representation. So through this, we can apply the probability concept to indicate. So here we are going to combine probability theory with some logic to handle the uncertainty, because it provides one particular way to handle the uncertainty, and we can assume that this will happen, but we cannot sure about it, this definitely will happen. So in that situation, we use probabilistic reasoning. So the next one, discuss about what is the need of probabilistic reasoning in artificial intelligence. whether this will happen or not happen. The outcome will be unpredictable. We can use this particular type of probabilistic reasoning, and at the same time, predicates become too large, then it is very difficult to understand. I think you people get some idea about first order logic and propositional logic in yesterday's class. Logic, if it is if it is involving two or three attributes, then it is okay. Otherwise, if it contains very difficult to represent and very difficult to understand the scenario. In what scenario this will happen? So in that case, probabilistic reasoning will do much better work. So when an unknown error occurs during an
Ma'am, slide is not changing, ma'am. It was in first slide.
now
Yes, ma'am.
now
Now
are
it
you able
is.
to see the need of probabilistic reasoning? Yes.
Now it is changed, ma'am. Now it is right.
Okay. Is it okay now?
Yes, ma'am.
Ways
Yes,
to
ma'am.
solve problems? Yes.
Thank you,
Okay.
ma'am. Thank you, ma'am.
With this, we are going to work with what are the ways to solve the problems which are under the category of probabilistic reasoning. So first one is, it is based on. So first we are going to discuss about the probability in brief. So probability, that you already aware that it can be defined as the chance that an answer. So we can get either head or tail. So the probability of getting the head is 0.5, and similarly the probability likelihood that an event will occur. So what is the likelihood of one particular event to occur? That will be represented with the help of this formula. So the value of probability, that this also we already aware, always so this probability of any event A to occur, the probability value must be in between 0 to 1. That is represented by the probability of A, that is event A, in between 0 to 1. So if this particular probability of A is to 1 means, then it is totally certain event in a particular thing. That particular event can happen in a certainty way. So if it is 0, it is totally uncertainty. If it is between 0 to 1, represents the level of uncertainty level present in our data set. So we can find the probability of an uncertain event by using the formula number of desired outcomes total outcomes, how many desired outcomes present. So the probability of not A is nothing but the probability of not happening that particular event from the probability values, which is possible to of happening that event A, and it should be used in this probability. Or the first one is event. So each possible outcome of your variable is called an event. Coin, or selecting a card from the deck of cards, selecting one particular card from the deck of cards. These are all examples for events. The second one is sample space. So the space, according to tossing the coin example, the sample space consisting of two events, getting the tail and getting the head. Then next one is random variables. So these are the data points or objects present in the real world. And the next one is very important, that is called prior probability. So the prior probability of an event is computed before observing new information. So this prior probability is calculated after taking all the evidences or after taking all the information into account. So it denotes, it is the probability that is calculated after taking all the evidences or after taking all the information into account. So this particular posterior probability is calculated using Is my screen is moving? Are you able to see the new slide, conditional probability? Anyone? Are you
Ma'am, screen is not changing.
now?
No, ma'am. It is in the need of probabilistic reasoning.
Share the PPT to you. Are you able to share the screen? Organizers? Organizers?
Sir, ma'am,
Yeah, I will send now. Next slide. Kindly keep it in slide share mode, sir.
It is okay.
We move to next slide. Yes, not this one.
Hello, problem. Ma'am, right side, no. You tell the number means we'll maximize that
Go to
particular slide.
go to slide number 7.
Okay, ma'am. Is it visible, ma'am?
Number 7. Yeah, this one. Shall I continue, sir? Sorry for the interruption. So here the network is very poor. So I gave the slides to Hosting Institute. So here what we discussed in our that is last discussion was event and what is sample space. Posterior probability. So the posterior probability is calculated by taking into account prior probability value as well as these are all the major terms which are used in the probability scenario. Next slide. Next slide. So conditional probability. Are you able to put it in slideshow mode, please? Slideshow mode.
Ma'am, it's not enabling.
Otherwise, shall I take over from you to me? Yeah, it's okay. Now it's okay. Now it is visible. Posterior probability. This conditional probability acts as the main thing which is used to calculate, which is the basis for Bayes theorem. So conditional probability is nothing but the calculating the probability of one particular or already happened. So this is the that's why it is referred to as conditional. Already one event can happen. So based on that, another event can happen in future. So that is the concept behind conditional probability. So here, if you want to calculate the event A, when event B has already occurred, can be written as probability of A and B means it is joint probability. Probability of B means marginal probability. So conditional probability can be written as or can be called as probability of B given A. The meaning is that already, that is the probability of A is given and vice versa is also possible. If the probability of B is given and we need to find the probability of A, then it is nothing but probability of A given B. So here the probability of B given A is calculated based on the and that will be divided by probability of A. So that we already know probability of A is already given and from the joint probability and the original already given marginal probability, we can calculate the new probability that is the So this can be represented with the help of Venn diagram. Next slide. So the Venn diagram representation one, and the probability of A and B is nothing but joint probability. So from this joint probability and individual probability value of A, we can identify the probability of B given A, and at the similar time, from the value of B, we can identify the probability of A given B. Next slide. The problem is, the problem statement is, let's show the problem statement. In a class, there are 70% of the students English and mathematics. So this is called joint probability. So two subjects are considered. So the students who like English and mathematics 40%. And we need to calculate what is the percentage of students those who like English also like mathematics. So let A is an event that the student likes English. So already the students, the 70% of the students who like English is given. That is the probability of B is given, and joint probability is also given as 40%. Therefore, if you substitute it to the formula, we are I mean the probability of students who like English also like mathematics is calculated by using the our formula, and 0.4 40% of joint probability, therefore it is represented by 0.4. 70% of probability of B, therefore 0.7, you get 57. So 57% of the students who like English also probability. So this is what happening in real time scenario also. So for example, if provided different conditions are given. What does that mean? One such a feature, the climate conditions, all the three features are given. So from these features, you need to identify first the joint probability. What is the probability of is able to play, and what is the probability of the person is not able to play from the given features. So likewise, you need to calculate the joint probability as well as conditional probability. From that only, you can calculate the posterior probability. Posterior probability is calculated prior probability information. Next slide. Next slide, please. So this is Bayes theorem. Bayes rule or Bayes law or Bayesian reasoning. So this particular Bayes rule determines the probability of an event happening with an uncertain knowledge. So it relates to conditional probability and the marginal probabilities of two is an application of Bayes theorem, which is very, very fundamental to Bayesian statistics also. So it is the way to calculate the value of probability of B given A with the knowledge of probability of A given B. So Bayes theorem allows updating the probability prediction of a theorem. Next slide. According to Bayes theorem, we can have two different laws. So these two laws provides the basis for Bayes theorem. One is called product rule, and another one is called conditional probability. Can write probability of A given B, that can be written as given B multiplied with probability of B. So this probability of A given B that we already know, real probability, and the probability of B is also probability of event B with known event A can be written as probability of B given A. So that is multiplied by probability of this rule formula. Probability of one event given another event. I mean probability of A given B is calculated from the likelihood probability of probability of A divided by probability of B. Here, most of the times, all the times, the probability of B should be 1 because it is the thing that can happen because already probability of A given B 1. So there is no need of that value probability of B is equivalent to 1 here. Therefore, if you substitute the value probability of B given A multiplied with the probability of A divided by 1, the same value you can apply. Therefore, in most of the formulas, this particular denominator value is calculated from the probability of B given A, likelihood probability and probability of A, prior probability. So the above equation is called Bayesian rule or Bayes theorem. This is very basis for probabilistic inference. Next slide. Next slide, please. No, previous one. Yes. Is very much important. So probability of A given B is known as posterior probability. That is the probability we are going to calculate. So that's why it is referred to as posterior probability. And it will be calculated. That is, you can read it as probability it is called probability of A given B. B event is already happened, so it is called as evidence and it is called as posterior probability. Second one is probability of B given A. So this is called likelihood probability. Provided given or provided whatever it may be the probability of A. So this is called likelihood probability which is already from the training data set you can calculate the prior probability. I will explain you clearly through an example so that you can get into idea of what is prior probability, what is likelihood probability and what is posterior probability. Posterior probability is always we are going to calculate. And it is calculated from prior probability multiplied with likelihood probability divided by marginal probability. So what is prior probability? Prior probability is probability of hypothesis before considering the evidence. So it is also available in the training dataset itself. And the probability of B is called marginal probability. So it is pure probability of a in general, we can write it as the probability of all events, any events AI given B that is calculated from the prior probability likelihood probability of B given AI divided by sum of all the marginal probability. Here all the values should be 1. Full posterior probability can be calculated from the prior probability and the likelihood probability. So this one we already aware that is sum rule, product rule and Bayes theorem. So product rule it is written as probability of A given B multiplied with the probability of B or probability of one is a sum rule. Sum rule is nothing but probability of A union B. It is calculated from the individual probability. Probability of event A to happen plus the probability of event B to happen minus probability of A and B. So Bayes' theorem any hypothesis to be happen given the entire evidence, the entire data set D, it is calculated based on probability of D given hypothesis into probability of hypothesis divided by probability of D. That I already told you according to total probability theorem. Inclusive and probability value, I mean probability, total probability should be 1. Therefore, the formula is that is revised, and the formula is the shortest form of the formula given D is equivalent to probability of D given H into probability of H divided by probability of D. That becomes 1. Therefore, probability of H given real probability, that is called probability of H. So it can be, if you replace the sample formula, this Bayes theorem formula into original events A and B, then the posterior probability of B is, that is probability of AI multiplied with the likelihood probability. Why it is called as AI means, I already told you, if there are 3 or 4 different features are there, then you have to take the probability of each and every feature. So that's why it is referred as AI. Next slide, please. Next slide, please. Their probability of D is total probability. I mean independent probability of the entire training data set D, and D given H is likelihood probability, and H given D is posterior probability. So we are going to calculate likelihood probability P of D given H and the prior probability P of H. Next slide. So from this we can come into 2 things. One is called maximum A posteriori hypothesis, shortly called as MAP hypothesis. Maximum A posteriori hypothesis for the given data set by using a formula called maximum hypothesis among the set of hypotheses available. The set of hypotheses is represented which are present in the hypothesis space is called H1, H2 small, H1, H2, H3 up to Hn. So you have to calculate the probability of H given D, and so if you elaborate probability of H given D according to Bayes theorem, it will be the probability, likelihood probability of D given H multiplied with the probability, prior probability of H divided by 1. Therefore, your maximum A posteriori hypothesis, MAP hypothesis, is of maximum of probability of D given H into probability of H. So you have to calculate the yes event separately, no event separately. For example, play tennis means yes, no. Similarly, if you want to calculate the floor belongs to which type of category, iris setos classes, you have to calculate the probability, and the maximum class probability will be the maximum A posteriori hypothesis. Hypothesis is nothing but your prediction value. For example, if the, what is okay. So capital H is nothing but set of all hypotheses. So we can drop probability of D because it is according to total probability. Same value can occur. So therefore, you can drop probability of D here. Shall we move to next slide, please? Maximum likelihood hypothesis. Next slide. Maximum likelihood. So equivalent to probability of Hj, where all Hi and Hj belongs to H. So here you can to this one, we can simplify the posterior probability calculation by using the formula. This maximum likelihood hypothesis Hmn is calculated by taking into consideration the maximum of hypothesis from the hypothesis set H, all the hypotheses for which event the probability likelihood hypothesis is high, that particular hypothesis will be considered as the maximum likelihood hypothesis. So next we So according to this particular thing, we are having very much familiar with now. Now we are having familiar with the probability of A given B, probability of B, and the probability of B, and the total probability. Okay, so from this we can have the Bayes rule: cause given effect is equivalent to probability of effect. So first particular example discusses about what is the probability that a patient has diseases, meningitis with a stiff neck. So here the data set is provided and the given problem statement is like this. The doctor is aware that disease meningitis causes a also aware of some more facts which are given as the known probability that a patient has meningitis disease is 1 by 30,000. So out of 30,000 people, one people can have a the probability that a patient has a stiff neck is 2%. One particular patient has a stiff neck is 2%. So from this, we so from the given data set, from the given problem, we aware that the A that is the probability of event A given B. I mean the probability of having with stiff neck. Here, meningitis disease is called the event A and the stiff neck is called event B. So probability of A given B is I already showed that 80%. So it is 0.8. Then the probability of B, that is the patient has a stiff neck, multiplying zero point 0.8 with the that means what is the value here you are having. Therefore, that particular thing is multiplied. This is your prior probability. Prior probability is 1 by 30. The probability is not 1 because it is given as 2%. Therefore, 0.02. Therefore, here if you multiply all these values and divided by 0.02, the probability that a patient has disease meningitis with a stiff neck is not 1%. Go to next slide, please. Another example. Consider from the standard deck of playing cards, a single card is drawn. So the probability of taking that particular card becomes king is 4 by 52. That you already aware. Then calculate the posterior probability given phase from the probability of phase given king into probability of already taken. So the probability of king card is 4 by 52, therefore it is 1 by 30. The probability of face card is 3 pins are available, therefore 3 by 30. Probability of the king, it is always 1. Therefore, putting it all the values into the formula, you can get into the value as 1. These two examples, I am switch over to a real-time data set, play tennis data set, which consisting of 4 different types of features or attributes: outlook, temperature, humidity. Plato is yes or Platon is no. There are two hypotheses, and that is the data set describes about 14 days whether play or not by the person. So for that, the test data set given us for the day sunny. Sunny means outlook value is sunny, temperature value is cool, humidity is high, weather data, today's weather condition, then the system has to decide whether it is possible to play or not, yes or no. Therefore, the hypothesis vacation problem, and we are going to predict what is the play prediction value for this. So here the x value, the test data set value is very strong. So outlook is equivalent to sunny, x is equivalent to outlook is equivalent to sunny. Are you are you able to? Is my voice audible, participants?
Yes, ma'am.
Okay, okay. So now we are going to calculate the hypothesis, prior probability. The previous slide, the data set slide, from the given data set, we can understand that out of there are 14 instances available in the data set. Out of 14 instances, 3, 4, 5, 6, 7, 8, 9 instances becomes I mean, play tennis is equivalent to no. So from the total 14 instances, next slide, here the play tennis probability of play tennis is equivalent to yes. Out of 14 instances, 9 instances belongs to yes category. Therefore, 9 by 14. 0.36. Next, we need to calculate the likelihood probability. So, what are all the likelihood probability we are going to give? For example, wind is equivalent to strong with play tennis is equivalent to yes. So, we have to consider wind with play tennis yes. With the play tennis yes value, how many values are available? Wind is equal to strong with the play tennis yes is 1, 2, 3. 3 values are available. So here out of wind is equal to total out of 9 yes instances. To know. So totally strong values. How many total strong values are there? 3 plus 3 must be strong with no. Therefore, out of 5 no instances, 3 instances are strong with by 5 is equivalent to 0.6. So next you have to calculate. Likewise, we need to calculate the probability of the first one. Outlook is equivalent to sunny given play tennis is equivalent to yes. Outlook is equivalent to probability of temperature is equivalent to cool. Temperature is equivalent to humidity is equivalent to high given play tennis is equivalent to yes. as for continuous data. Also for continuous data, the formula is something different. For categorical data, the formula is the posterior probability is calculated by multiplying participants. Do you have any doubts till this point? Network. Shall we have a break and after that shall I continue that part? Fine. Shall we join at 11:45? Time is 11:20. 11:45. Shall we resume our session?
Hello, ma'am. Hello, ma'am.
Now let us resume our session.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
Okay. So now let us resume our session with the Bayesian belief network. Till now we discussed about prior probability, likelihood probability, and how to calculate the posterior probability with one particular example. So now let us move on to the second concept in this probabilistic reasoning, that is Bayesian belief network. So this particular terminology is dealing with probabilistic events and to solve the problem which has again uncertainty. For solving uncertainty type of problem. And Bayesian network is defined as it is a probabilistic graphical model, shortly called as PGM. A set of variables and their conditional dependencies using a DAG. DAG means directed acyclic graph. So as usual, on a decision tree. So in that we are going to construct the tree based best feature, I mean best split feature, and based on the best split feature the entire data set is split into subsets, and for the subsets the tree may be constructed, and this process is repeated until all the create a network of nodes, and each node represent the conditional dependencies structure, and it is of DAG in nature. That means directed acyclic graph. Another name given to this particular Bayesian belief network, Bayesian model, and it is also probabilistic nature. And these networks are built from a probability distribution only. So that's why it is referred to as it's in probabilistic nature. And it also uses probability theory for prediction and anomaly detection. For example, lot of information retrieval real world applications or this particular real, or you see my screen changing? Anyone tell me? Anyone?
Yes, ma'am.
Second, next slide. Bayesian network.
Yes.
Okay, thank you. Okay. So applications of this probabilistic thing, we can say that anomaly detection, for example, prediction, diagnostics, various in help of Bayesian belief network, automated insight, reasoning for failure of the machineries, time series prediction. I mean weather forecasting and so on. Time series prediction, and where what are all the places where the decision making is happening under uncertainty, whether this may happen or will be used. So it can be used for bidding models from the available data and experts' opinions. So based on these two things that were consisting of two different parts, one is called directed acyclic graph, and another one is called table of conditional probabilities, or shortly called as conditional probability table CP. Directed acyclic graph DAG, and from that we need to construct the CPT, that is conditional probability table. Image, and this particular diagram it is used to represent the scenario Bayesian belief in Bayesian belief network. The sample scenario, example scenario is represented with the help of a diagram called screen. So this particular Bayesian network graph consisting of four nodes and four different arcs. Arcs means directed links are present and it is used to connect the nodes between each other. And here A, D, B means here the node A is called parent node and it is connected with C. So here we can say that this particular C node is one or another way. That is, it is not possible to link with A. Therefore, it is independent of node A. Whereas node A is parent of influence diagram. So here we are having each node corresponds to random variable. For each and every variable, we need to create or we need to draw one node. And this particular variable can be of continuous data type or discrete data type in nature. So it can be used for both categorical data between A and D. Go to the previous slide. Here we are having the relationship between A and B. The help of this arrow or direct arc or directed arrows. So these one connect the pair of nodes in the graph. So these links normally represent whether one there is no directed link, then the meaning is that those nodes are independent with each other. So that is the reason I am telling about. So if you are having four different nodes A, B, C, influence diagram, A is directly connected with D, therefore direct relationship between A and D. Similarly, A is directly connected with B, therefore direct relationship between A and B. A, therefore it is independent of the node A. So node A is called one particular that is node A is called the one random variable. Node B, C are different random variables are present. So each and every random variable we have to construct the node. So independent with each other. So in the previous example, A, B, C which is connected with node A by the directed arrow, and particularly node A is called the parent of node B. Similarly, node A is called the parent of node D, whereas node C is independent of connection between node A and node C. Therefore, node C is independent of node A. So the Bayesian network graph does not contain any cyclic. So if you see the representation, it is not a cyclic graph. Therefore, that's why it is the reason it is called as direct. Are you able to see my screen? Screen change? Two different types of Bayesian components, Bayesian belief network components. One is called the causal component, which leads to causal analysis, and another one is called actual numbers. So each distribution with the representation that probability of xi given parent of xi. So what is the meaning of this? Means this is used to determine example what we discussed in the previous slide. So here you can say that the probability of D can be calculated with respect to the probability of the parent its parent A. Similarly, the probability of probability of D given parent of D. Similarly, the probability of B given the parent of B. So there are two different probability distribution. So Bayesian network is mainly based on joint probability distribution and the conditional probability distribution. Likelihood probability Bayes theorem is therefore it is purely based on the posterior probability is calculated based on prior probability as well as the likelihood probability. Whereas here in Bayesian belief network, joint probability distribution we need to take it into account. So for example, if we have a set of variables x1, x2, joint probability distribution. So for example, the probability of x1 probability of x1 given x2, x3 up to xn multiplied with probability of x2, x3 up to xn. This is one way. And of x2 given x3, x4 up to xn. So it will be go on until probability of so that is multiplied by the probability of xn. So this is what in general we can write in any one of the case. They can be used in general for each variable xi. We can write the equation is probability that will be calculated based on probability of xi given parent of xi. So child probability and joint probability distribution is calculated based on the probability. That is what we discussed in the this particular slide. It is calculated based on the parent node. So the probability of D is calculated provided the probability of parent of D. Similarly, the probability of joint probability of B is calculated providing the probability of its parent, B's parent or parent of B. One particular example is given here. What does that mean? Harry installed a new burglar alarm at his home to detect burglary. So the alarm reliably responds at detecting a burglary, but also responds for minor earthquakes. So what is the meaning of this? Means Harry installed a new burglar alarm to so, but he is always out from his home, then he depends upon two persons. So the alarm reliably responds at response for minor earthquakes. So the alarm is mainly used to detect burglary and mini earthquakes can also detected by the same alarm to inform Harry at work when they hear the alarm. So these two persons, when they hear the alarm sound, they have to intimate the current calls Harry when he hears the alarm, but sometimes he got confused with the phone ringing and calls at that time too. So what happens? So not ringing. So by considering his own phone sound, he assumes that alarm is ringing and he made a call to Harish. That is what happened. On the other hand, Sophia likes to listen to high music always. So sometimes she wishes to hear the alarm. Position to inform this particular alarm even to Harry. So here we would like to compute the probability of burglary alarm. So what is the problem is? Problem here is that calculate the probability that alarm has ringing but there is neither a burglary nor an earthquake occurred. So, no burglary, no Sophia both called the Harry. So, what is happening? How to represent this particular scenario? So, with this Bayesian belief network, we can represent this particular scenario. So, the Bayesian belief network for the above problem is that the network structure is showing that diagrammatic representation of this. Okay, so this event by B, and happening of earthquake event is represented by E, and David make a call to Harry means that it is represented by D. Sophia makes a call to Harry means that it is represented. This alarm consisting of two alarm is happening. Alarm is the event that is to be happen. And the earthquake is another parent event. So as a consequence of this alarm ringing, either the neighborhood, two neighborhoods, either David or Sophia makes a call to Harris to inform that this particular alarm has ringing. So here you show it to you also, and directly affecting the probability of alarms going off. But David and Sophia parent node, okay, and David and Sophia's calls depends upon the alarm probability. So it is a hierarchical representation. So the network is representing that our assumptions do not directly perceive the burglary and also do not. So here all is called negative conditions. So problem statement. See clearly the problem statement. Calculate the probability that alarm has sounded. That is positive, but there is neither a burglary nor an earthquake occurred. But the alarm is sounded. So what he has to do? The David and Sophia both called the Harry in a wrongly way. So here and do not directly perceive the burglary and also do not notice the final earthquake. And they also not confirm before calling. So these are the table shortly called as CPT. So the system has to design the conditional probability table. So each row in the conditional probability table must be sum to 1 because each row, keep it in mind, each row in the CPT must be sum to 1 because all the entries in the table represent an exhaustive set of cases for the variable. Lot of in conditional probability table, a Boolean variable with k Boolean parents containing 2 power k probabilities are there. So, hence, if there are two parents, then your for 2 power 2, that is 4 probability values, the conditional probability table will contain. Dear participants, do you have any doubts till now? So here list of all events occurring in this network are: first event is burglary event represented by B, second event is earthquake event represented by E, third event is alarm event, the alarm ringing event. David make a call to Harry, then it is represented by event D. Then the last event is Sophia make a call to Harry, then it is represented by yes. Now it is important. So with respect to probability, we can write all the events. So here I am taking only one event. Denotes David, S denotes event of making a call. Sophia make a call to Harry. Then what is A? Anyone? What is A? Alarm event. What is B? Burglar event. And what is E? Anyone? we are having 5 different events. So we can rewrite the above probability statement using David Sophia make a call based on the alarm sound. Alarm sounds based on the events either burglary or earthquake. So the probability of DSA all the events to happen multiplied with probability of S given alarm, burglar and earthquake event to happen. So this probability of D given SKBE multiplied with probability of S given Sophia given ABV, okay, and it is multiplied with probability of what is the all the 3 events. So either earthquake or burglar can happen means alarm will ringing. So the probability of ABE that is represented is written as probability of D given A. So David make a call due to alarm sound multiplied with probability of Sophia makes a call given ABE and multiplied with probability of ABE. Now this statement is again reproduced with the help of probability of David make a call given alarm multiplied make a call given the alarm multiplied with probability of alarm is ringing either based on any one of the scenario, either earthquake can happen or burglar event to happen, and it is multiplied with probability of B comma E. Again, the above statement can be comma E multiplied with probability of B given E multiplied with probability of E. I don't know how many of you understand, but this is the basic one. So in which way we can calculate burglar given earthquake. Third one is probability of alarm ringing given alarm will be ringing. And next one is that is probability of Sophia make a call to Harry provided alarm is ringing. So this is the actual solution. The table shortly called as CPTs. So CPTs are nothing but conditional probability table. By B, earthquake event represented by E, alarm event represented by A, David make a call to Harris represented by D, Sophia makes a call. Calculate the burglary. For burglary, there are 2 events to happen. Really, burglary can happen or not happen. Therefore, it is represented by true or false. Similarly, for earthquake, really earthquake can happen or not happen. Therefore, it is also represented by true and false. Whereas alarm is depending upon number of possible combinations are 2 power to 4 different combinations. So the first event is earthquake can happen, and the one is the probability of alarm ringing due then probability alarm is not ringing and it is represented by true and false. True means alarm is ringing, false means alarm is not I mean not ringing. Not ringing in the sense it can be used to, it cannot be ringing, but due to that member's phone call, he misunderstood that the alarm is running and he made a call to. So this one can happen simultaneously, or that you already aware. If two events can happen, means then four different combinations. Burglar is happening, true, and earthquake is also happening in the same place. So true, true. Second one is burglar is happening, but vice versa of second one. But burglar alarm is not happening, but earthquake is happening. False, true. So both burglary is not. So that the probability of alarm ringing with true, how much the probability of alarm ringing with false. Last part is David calls and Sophia calls. So David calls means alarm. Either David or Sophia calls means the immediate effect is the action of this effect is alarm is ringing. So here alarm with true and false values. Equivalent to true and probability of D is equal to false. These four values you need to calculate, and similarly Sophia make a calls again the same thing. A instead of A is here also true false. Probability of S equal to T, and another one is probability of S equal to false. So these are all these tables are called the observed probability for the burglar and the earthquake component. So the probability of burglar alarm or burglar can happen. Burglar you have to take if the burglar alarm is ringing represented like this. If the alarm is ringing due to earthquake, then the true and false values are represented like this. If David makes a call, then it is represented like this. If Sophia makes a call, then it is represented for different combinations. So the probability of burglar is equal to true is point, not 2 from the table. The probability of burglar is equal to cast. If you add these two values, it should be 1. That you can remember. That you can remember it should be 1. Probability of burglar is equal to false is 0.998. The probability of earthquake is equivalent to true is equivalent to false is 0.999. This one. This one, 0.999. Therefore, true scenario point not 1. If you add these two, then it will be 1. That one you have to keep it in mind. Is equivalent to point not 1 means there is a minor earthquake happen. Earthquake happen in a minor way. Probability of 0.999. Are constructed from the for the given problem. So here this is CPT, shortly called as CPT, conditional probability table for alarm A. So here the conditional probability of alarm A depends upon two parent nodes. So event earthquake event probability of alarm ringing is equal. So here we are having all the four combinations: true, 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 false, false, true, and the second table is called the conditional probability table of David make a call. That he will call depends upon the probability of alarm. So for that, David is equal to probability of David is equivalent to true and probability of David is equivalent to false. So here you have to include only true value is considering, the second one is the false value is considering. The values will be represented as true is 0.91% and 0.91 and false is 0.05. Similarly, cannot make a call, false call. Probability of making a false call by the David is 0.09 is true and 0.95 is false. So the meaning is that here if you see the values 0.9 values leads to accuracy. Therefore, it should be high. True value probability of David make a is 0.91. False alarm sound is 0.05. Small value. And similarly, David make a false call while actually happening. This true but David does not make a call. That is 0.09%. Alarm is not happening and David is also not making a call. This is true. These two values according to confusion matrix representation false true and false conditions. These two values 0.91 and 0.95 leads to accuracy of the model. And implicit. The next one is conditional probability table for Sophia. I don't want to explain because the same that is calling David calling based upon the alarm to Harry. Similarly, Sophia call based upon the alarm to Harish. Making the call provided the alarm is also ringing. So true scenario is 0.75. Are you able to see my screen?
Ma'am, I think the slide is not moving. It's in a solution slide.
Yes, solution for Sophia make a call. Am I right? No. This one probability values.
Yes, ma'am.
Now,
This slide only
now is it
shows.
moving? Are you able to see?
It,
The table for alarm
um,
A. No. Just a minute. I'll stop sharing. Okay, in that case, I'll make share now.
just now only the loading, ma'am. Screen is loading.
Oh, okay. Here it is loaded.
I think both the screens are sharing. I think so.
Now, probability value. Again, there is a problem. I stop present. Screen.
Yes, ma'am.
With the probability values.
Yes.
Shall I repeat once again? These values. Are you able to see the conditional? I repeat from here. So what is happening here means this is what actually the problem is that the alarm can happen when burglary can happen or then when the alarm rings either David make a call to Harish or Sophia make a call to Harish. So this is the actual problem. But the problem given here is that what is the probability? You have to calculate the probability that alarm has sounded, but there is neither burglary nor so this is what no, there is no event happening. Burglary is not happening. Earthquake is also not happening. But wrongly, since David and Sophia make the call to Harry. So what is the probability for this event to happen? That is the question given to us. This is the problem given to us. So in order to solve this problem, we need to first
I'm
event
absent.
screen. Okay. Suppose if it is not moving, tell me immediately. So is used to denote the event of burglaring can happen. Earthquake can happen is represented by E. Alarm ringing is represented by A. Harish is represented by S. So this is what the sample probability. So joint probability distribution. So probability of first one is David make a call, or the second one is Sophia make a call based on alarm sound. Alarm sound is based on two events. One is burglary event and another one is earthquake event. So this can be rewritten as probability of D given Sophia make a call, and another one is probability of probability of D given SABE multiplied with probability of Sophia make a call on probability of alarm happened due to B and E. I am telling shortly. The next thing is again the previous equation. David make a call after getting the alarm sound multiplied with probability of Sophia given ABE multiplied with written as the probability of D given A, probability of S given A, I mean probability of David make a call based on alarm sound multiplied with probability of A alarm is ringing due to burglary or earthquake, and it is multiplied with probability of this is E comma E. And again this statement can be rewritten as problem of that is probability of Sophia make a call provided with alarm. Probability of alarm is ringing provided with either burglary or earthquake event can happen multiplied with probability of earthquake or probability of earthquake. So based on these events, this is one combination. On that only the problem solution will be given. So for that we are in need of conditional tables, probability conditional tables or conditional probability. The conditional probability table for burglar event to happen. So this and false. Whereas David make a call here alarm. Alarm is the it depends upon two different events. Burglary. For 2 power 2, 4 different combinations can happen. So the probability of alarm equal to true, the probability of alarm is equal to false for both the events. So both the events, both burglary is also then what is the probability of alarm is ringing? If both the events are happening, what is the probability of alarm is not ringing? That is represented in the first row. And second one is not happen, but what is the probability of ringing the alarm and not ringing the alarm? Alarm is not working. Similarly, again the reverse sign. Only earthquake is happen and burglary not happening. This is the thing we want. See carefully. This is our problem statement also. No burglar and happened. Neither burglar nor earthquake is happened. But both. Okay, so that is the reason. So here, if both the things are not happened, the probability of alarm to sound is 0.999, and similarly, the probability of alarm not ringing is also 0.999. So here, David made a call to Harish means alarm value may be true or alarm value may be false. So here we are having the probability of David is equivalent to true means David make a call to Harish provided alarm is also ringing is 0.91. David make a wrong call to Harish. David make a wrong call to Harish provided the alarm is not ringing is 0.95. So two row values it should be 1. If you add the column means if you consider the column, if you add these two values it should be 1. If you add these two values that should be 1. But here also the row values should be 1. In a similar way, David make a call in a similar way. So if you make a call, what is the probability of making a true call and making a false call provided alarm is ringing is true, alarm is not ringing is false. Shall I proceed? Anyone please respond me? See, are you able to see the screen with the probability value? Yes, okay, thank you. So now let us come to the our problem. What is the observed probability for the birth? These values will be taken from this conditional probability table. Why not to? And the burglar cannot happen is similarly probability of earthquake to be happen is 0.001 and probability of earthquake not happening is 0.999. So based on these four values, I am going to calculate the conditional probability table for alarm A. So alarm. So burglar can be because of both the events we can get into four different combinations: true, false, false, true, and false, false. I think you people are aware that what is the meaning of these four things and the corresponding probability. Next, we move to the conditional probability table, the table for David make a call to Harish. So it depends upon the probability of alarm. So alarm probability can be of true and false. 0.91, false means 0.09. If you add these two, it will be 1. Similarly, it will be 0.05 and 0.95. I already told you. So this particular alarm is true. David does not make a call to Harish. So these diagonal values 0.91 and 0.95 leads to accuracy of our algorithm. Whereas this particular make a call to particular Harris provided alarm is ringing and does not make a call to values. The first one is alarm is ringing, but he is not making a call. This is point not 9. Second one is the alarm is not ringing, but David make a call. Not 5. So these two values, point not 9 and point not 5 values leads to error. So according to confusion matrix representation, these accuracy of the model. Similar way, you can calculate the conditional probability table for Sophia, make a call. So once distribution formula, so the probability of Sophia and David make a call on alarm, but alarm is ringing, therefore alarm is positive. Listen carefully here. Alarm is ringing. Therefore, Sophia make a call and David also make a call. Therefore, probability of Sophia S.V.A. provided. What is happening means not B, not E. That you have to calculate. So this will be calculated based on the probability of Sophia make a call to Harish given alarm is ringing multiplied with probability of David make a call to Harish provided alarm. There is no burglar and alarm is ringing provided there is no earthquake. That is represented by joint probability and not E. And it is multiplied with the prior probability. Probability of not ringing, that is not happening, not happening earthquake. So from the tables, you have to refer all those values. And if you substitute from this, we can understand that the probability of so if there is no burglar and there is no earthquake can happen, but alarm is wrongly ringing, in that case, Sophia not 68045. So this is very small. From this is mainly used for calculating this particular type of um, probabilities of joint probabilities in the sense. So either any one of the event can happen or one happen either burglar or earthquake happen means then alarm is ringing. Alarm is ringing means it